Okay, apologies for late start because I should not say that, but I just need to say sorry that I'm be busy for many issues and for my family, for the work, for something like this. And but at least the good news, I have a little bit of budget, as I mentioned in the beginning of the semester, and we can have some food testing next week and next week. Okay, so later I think I will have a short questionnaire or a non-official survey about your food, your dietary restriction. For example, someone cannot eat special issues. For example, I remember your class this class. Some of you reported that you cannot eat chicken because allergic or something, some issue like this. Sure, I will prevent to use meat or seafood because I know some are vegetarians. And so next week, I hope everyone can enjoy my snacks. snacks. Okay, and today we will continue to move to the chapter 9.3. And again, we try to calculate by easy steps. Later, as I mentioned, I will show you some useful, powerful website applications. Just type the information inside. Then you will get the answer in a few seconds. You did that? You did that? So you trust my words here. Okay. Independent sample for two means. What does it mean? In our oral language, we call it test two samples of means. Are they the same? Sure, in the professional language, we will not say they are the same. We will say, after our analysis, there is no significant difference exists among those three or between two groups. But in our language, we call it they are the same. For example, if I created a brand to sell the detergent, wash your dishes, wash your kitchen, something like this, and I claim the detergent is very powerful. Even the efficacy is close to the top one brand in Taiwan market. If I claim this, I need to do the experiments, and after maybe 20 times, 30 times, many times of the testing, I will run this test and say after our testing, detergent, they can clean your utensils very well, even no significant difference to the top one brand detergent. That is this moment. If you are the second one, maybe you are top two, top three. You want to approach the top one brand, the product. You hope those significant difference is not existed. If want to know if I drink black tea, if I drink green tea, if I drink oolong tea or something, for tea, something like this, I expect the oolong tea, the black tea, the green tea can lower my blood pressure, my blood cholesterol, my blood sugar, something like this. And I expected after the testing, if the significant difference is existing, that would be better. That'll be better. So it depends on your purpose. Again, if you are the top three, top four, top five brand of a product, you want to approach even over, if you want to approach the top one brand, detergent, car, or some machine, something like this, you say our efficacy is very close to the top one brand. Then after this testing, you can say that if you, I drink black tea every day, and among maybe 100 people drink black tea, the other 100 people, they don't drink. After that test, their blood pressure or blood cholesterol are significantly different. And there is a strong evidence that black tea can lower the blood cholesterol. You need to show the evidence, okay? Let's move. This section will look at how to analyze when two samples are collected and are independent. Sometimes the language is not so good. In easy oral language, I would call it, they are different. They are different. As with all hypothesis tests and confidence intervals, the process is the same, thought and the formulas and assumptions are different. Okay. The only difference with the independent t-test as opposite for the tests that have been done is that there are actually two different formulas to use depending on if the particular assumption is met or not. First one, hypothesis test for two sample t-test. Sure, in the future you can search for many free online applications. You can type the keywords two sample t-test. X1 random variables 1, X2 random variable 2, mu the mean of random variable 1, mu2 the mean of random variable 2. Okay, state the non-hypothesis mu1 equals mu2, or mu1 minus mu2, that is 0. Alternative hypothesis, that is not equal, greater than, smaller than, or not equal. Then it is move. State and check the assumption. Okay, the random number of size n1 is taken from population 1. Random sample number of size 2 is taken from population 2. Okay, no problem. Okay, this time, as I mentioned, if I produce a very useful detergent to wash your dishes, to wash your kitchen utensils, I try to select some samples to test the efficacy of my detergent. Population is my detergent. I select maybe 10 times, 20 times to clean dishes. And population 2 could be the top 1 brand detergent. Sure, I have no idea what kind of detergent is famous in Philippines, but in Taiwan there are at least 4 very famous brand in Taiwan. Some brand they sell cheaper products. Okay. The samples do not need to be the same size, but the test is more robust if they are. Okay, maybe sample 1 20, sample 2 30. If the number is the same, it could be better. Two samples are independent. Okay, population 1 is normally distributed. Population 2 is normally distributed. Just as before, the t-test is fairly robust to the assumption if the size is large. This means that if the assumption isn't met, but your sizes are quite large, for example, over 30, then the results of the t-test are valid. The population variance are unknown. Population variance unknown. Thus, we do a little bit experiment. We select some samples and not assumed to be equal. The old assumption is that variance are equal. However, the assumption is no longer the assumption that most statistics use. This is because it isn't really realistic to assume that the variance are equal. So we will just assume the assumption of the variance being unknown and not assumed to be equal. That's true. Okay, let's move. Find the sample statistic, test the statistic, and p-value. Here, calculate x1 bar, x2 bar, standard deviation 1, standard deviation 2, number 1, number 2. Then the t-value of t-score equals here, x bar minus x bar 2. Then minus mu1 minus mu2 and divided by square root of this one. I think it forgot a division symbol here. Okay. Then the degree of freedom is a little bit ugly, like this one, where A is like this, B is like this. The p-value is here. No, let's move. And this part, sure, I will run an example. I try to ask you to do this. And later, as I mentioned, if you have enough data, you can type and calculate in a few seconds. Okay, let's move. Okay, hypothesis test for 2 means the cholesterol level of patients who had heart attack was measured 2 days after the heart attack. The researchers want to see if the patients who have heart attack have higher cholesterol level, like this one. Okay, let's move. A random sample of 28 cholesterol level of patients who had a heart attack is taken, and a random sample of 30 cholesterol levels of healthy individual is taken. The problems does not state if the sample whether random selected. And so this assumption may not be valid. Okay, like this one. And it looks normal distributed, like this one. Like this one. Okay, and let's check here. So doesn't look linear. So the population overall cholesterol level of health is probably not normally distributed, and this assumption is not valid at the second sample. Since the sample is fairly large, the t-test is robust. It may not be an issue. However, just realize that the conclusion of the test may not be valid. Okay, because the healthy group, the individuals, their cholesterol is not normally distributed. But it doesn't matter. We can run the test. And the t-test is about 6.015, and the degree of freedom like this one. At the test, we can check it. Okay, thus reject non-hypothesis since the p-value is smaller than alpha, and the conclusion is this is evidence to show that patients who had heart attack have higher cholesterol on the average from healthy individuals. And though to realize some assumptions are not valid, so this interpretation may not be invalid. But roughly, we have this one because the healthy individuals, their cholesterol level are not normally distributed. Okay, let's check this. Okay, and now to sample t-test calculator. Yeah, there are very many useful tools. For example, I can use this or this. I'm going to pass this one to you. Okay, sorry, I may postpone the break time. Okay, and now enter raw data or paste Excel data. For example, if I paste the data here, and I can select the data here, copy, and paste. Okay, let me try. Then set the two tails. Okay, significant level 0.5 and effect median. Standardized effect outliers include effect size 0.5. Then I can click calculate. And we can compare the results with that. Sorry, I think I need to change it. From the first, oh, sorry. Sorry, the website is shut down. Let me do it again. Okay, here we have some samples of about the cholesterol level of heart attack patients here and healthy individuals here. And a random sample of 28 cholesterol levels of patients here, and the other 30 normal people, their cholesterol level are here. Then let's move. Okay, and we know the t-value is 6.1 and the degree of freedom 37, p-value very, very small. We can check the result here. Oh, sorry. Okay, let me do that. Oh, sorry, something wrong with this. Oh, I think I need to switch to the website. 1 minute, please. Then I can select the first 28 patients about their cholesterol level. What's wrong with that? Oh, sorry. Oh, okay. Sorry. It's much better now. And the second column of data for healthy groups. Copy, and here then click calculate. Okay, the value is less than 0.001, very small, and the mean of the first group, the cholesterol, is 253, and healthy group 193. Standard deviation 43, 22. Then and the t-test about the t-value, the t-score is 6.2, degree of freedom 56, very close to the here. But I don't know why that's different here. Okay, then we can go to conclusion. There is enough evidence to show that the patients who had heart attack have higher level cholesterol on the average from the healthy individuals. Okay, please try this. Personally, I think this website is okay. And the first website, or you can test a different website, but the keywords is 2 sample t-test. And as I know, sure, you can got the means and the standard deviation, then select the answer here. Okay, maybe later we can try this website. We will get a similar results. Okay, sorry to postpone the break time and have a 10-minute break. Then we will come back and check the attendance.